All right, guys. So we're finishing up the routing section. Okay. And so last time, right, we went over reverse path forwarding, right? And so we're still going to touch on that a little bit here, but we're going to add in another topic that we talked about, which is ECMP, right? Equal cost multipathing. Okay. And what is that, right? So whenever we went over that before, we realized that if you have multiple routes of the same path that have the same attributes, they can be installed inside the routing table, right? And what the Fortigate can do, okay, because we're just focused on Fortigate, I don't care about anything else. The Fortigate can distribute traffic across all of those links that have the same values, okay? All right. But remember, to be considered for ECMP, okay, routes must have the same values, right? So destination subnet, okay, distance, metric, and the priority, okay? All right, so let's talk about the lab that we have here, okay, how we're going to test this, right? So we have our source subnet, right? And we have our destination subnet, okay? Right? And we have our WAN links, okay? That's covered in yellow, all right? And so with our WAN links, we have 3 WAN links, okay? And so port 2, port 3, port 4 on each side, okay? They have been configured, right? Static routes have been configured. I did not manipulate the distance. I did not manipulate the metric nor the priority, right? And they're going to the same destination subnet from the source, okay? All right, so let's go ahead and take a look, right? And let's go ahead and see how it looks within the routing table, okay? So let's go ahead and hop on, um, let's go ahead and hop on HQ1, okay? All right, let's do this. All right, so let's bring this over here, all right? All right, let's go ahead and log in. All right, so first things first, we want to go ahead and take a look at that routing table, right? How do we do that? We're gonna do get router info, right? Routing table, all, okay? So we want to go ahead and take a look at this, right? So if we go ahead, take a look at it, what do we see, right? We'll see our destination network, which is 172.16.1.0/24, right? And what do we expect to see knowing the theory of equal cost multipathing, right? Is we see for the same destination, we see 3 routes installed inside the routing table, right? And so ECMP routing is happening currently, right? So it's going to take one of the 3 links, right, and balance that traffic between them, right? Now, right, from a foundational theoretical standpoint, that's what it's supposed to do. But remember what we learned about. We learned about the ECMP methods, right? So what are the 4 methods? We have source IP, right? Meaning that whenever a session begins, right, from the same source IP is going to use that same route, right? So if PC5 uses maybe, port 2 on the FortiGate to, go ahead and travel to the destination subnet, it's only going to use that, right? If we had another PC on the same subnet and they use port 3, it's always going to use port 3. That is source IP, ECMP method, right? We have source destination, right? Source destination IP, right? Sessions with the same source and destination IP is going to use the same route. So similar to the default one, right? But it's a little bit more granular, okay? Weighted, right? The weighted ECMP method, right? Sessions are distributed based on route or interface weights, okay? All right. And also, of course, in the last 2, the weighted, and of course, the next one I'm going to mention, which is usage, you'll typically see those. You won't see those in a SOHO. You would typically see those in a data center setting. My experience so far has shown me that you would typically use those in a data center setting, or you would just go ahead and use SD-WAN to go ahead and control WAN optimization. Okay, but usage, right? It is an ECMP routing method, right? And again, its usage, the usage method means that, of course, one route will be used until the volume threshold is reached, right? Then, of course, the next route is used, right? Another word for the usage ECMP methods is called spillover, right? So let's go ahead and see some of this in action, right? So we saw the routing table, right? We see how that looks. Let's go ahead and see where we can go ahead and manipulate the ECMP methods, right? Let's go ahead and go to the CLI because that's only where we can manipulate it. Let's go ahead and go to the system settings, right? And let's do a show, right? We see nothing configured, right? If we wanted to go ahead and manipulate the ECMP methods, we would go here, right? And of course, we can see all of the options I'll share with you. We can keep it source IP based, weight based, usage based, and of course, source destination IP based, right? Like I shared with you guys, the source IP is the default, so no need to go ahead and change it, right? If we were to go ahead and select weight, right? If I go ahead and set it to weight, right? I need to go ahead, right? I need to go ahead and manipulate the weight of an interface, okay? Because that is the only way I can manipulate the weight, right? And I would go ahead and say, right? I would go ahead and say set weight, right? And I would enter a value for that, okay? Right? So it can, you can set the weight in one or two of the ways, right? Let's go ahead and hop out of here. So you can do it on the interface, or, right? Let me show you something else, all right? You can add a weight to the interface, or you can add a weight to the routing table, okay? So since I'm focused on what, port 2, I can go ahead and say, right, edit 1, right, because it's my entry for port 2, and I can say set weight, right, and we can go ahead and do it there, okay? All right, all right. So let's go ahead, revert back, right? And before I do that, I want to show you guys another option. Okay, we're gonna go ahead and set it to usage, right? So how would we configure that, right? We would only be able to manipulate the usage or the threshold, right, on the interface, okay? And of course, to do that, right, I would go have to use the keyword spillover threshold, right? And of course, I would have to go ahead and enter a value for that, right? And of course, that threshold would mean, right, if, right, I have a gigabit interface, right? If my gigabit interface hits, that's maybe connected to the WAN, right? So whatever I set it to, right? Maybe I have a 300 meg length, right? Maybe I set up the SLA and what have you, and I want to set the threshold to 70%. I would set that, and that means, right, my next WAN link, after it hit this threshold, would go ahead and transfer all traffic now to go to another port, right? Another WAN port, okay? And again, this is all, you would do all of this manually, and it would require you to have some type of knowledge with routing, okay? All right, so please test this out in your lab, see how it is, have fun with it, don't be afraid to make mistakes. It's all good. So let's go ahead and um, set this back. There we go. Okay. There we go. All right, so we got everything set back. Let's go ahead and let's look at that routing table again. All right, so we got our routing table. We're good to go. All right, let's check our other side. Let's check our other routing table. Let's check HQ2. Right, and of course, prior to this, I went ahead and did the firewall policies as well. So let's go ahead and test it. Excellent. Get router. Go. Go. There we go. Right. All right. So we have it on the other side too. Okay. But what do you guys notice? Right. Because remember, we went ahead and went over reverse path forwarding. Right. So, Mike Hevia, if I'm sending traffic, right, and now we're combining theories of ECMP and reverse path forwarding, right, RPF. If I'm sending traffic from PC5, all the routes and all the firewall policies are in place. If I'm sending traffic from PC5 to PC6 based on the routing table that you see, right, for both firewalls, is PC5 going to be able to ping PC6? Why or why not?
I'm gonna say yes, it will be able to ping PC6 through the route of 6.4.2.
Look at it again.
Okay.
Remember, we're combining two theories, ECMP and reverse path forwarding.
Okay.
And guys, you can help her out as well.
Please.
I would say yes because of the 172.16. Oh no, that's not two.
Oh wait, I guess no, because it doesn't have a
A
hop
route.
1772.16.2.
Yeah.
There we go.
So I say no.
No.
There we go. There we go. There we go. Right? Right? So, because again, RPF, what is it doing, right? If it's sending traffic out, the first thing it's going to do before that packet egresses the firewall is it is going to check its routing table first to see if there is a route back to the source. If there is not a return path, and I need you guys to remember this for your exam, with the RPF default method, if there is not a route back in the routing table to where the source came from, it will drop that packet, right? And again, guys, the purpose of RPF, right? It's a mechanism to go ahead and protect the Fortigate and your network from IP spoofing attacks. Okay, so we need a route. We need a route in the routing table, right? For these networks that are, that is sitting off a different VLAN on those switches. Okay, make sense?
Yep.
All right. So
Yep.
let's go ahead and test this out. All right. Let's go ahead and add that route to these firewalls. Okay. So let's go ahead. All right. All right. So this is that, right? And our network that we mentioned is 192.168.2. All right. So let's go ahead and create a static route for that. All right. All right. Our gateway is going to be 192.168.1.1. There we go. All right, now let's do it to the other one. All right. Excellent. Let's go ahead and do the same thing. Almost looking work. There we go. All right. So with everything in place, let's go ahead. All right, let's go ahead and start capturing some traffic. Go ahead. Let's do a packet capture. All right, so we got it running. All right. Let's go ahead. Well, we only need one. That's fine. Now let's try to reach out to that other subnet. All right, and we got a fail. Let's go ahead and take a look. There we go. All right, we'll go ahead and allow it to do a continuous thing. Let's make sure we got our routes everywhere. Where are we at?
And the policies are in place already, right?
Yes, sir. Let's go ahead and take a look. There we go.
Yep.
Let's go ahead and take a look at these switches since they're operating at layer 3. Oh, wrong screen. There you go. All right. Let's just switch 3. There we go. All right. X. Yep. And that's our issue. So what do you guys see here? And I'll give you guys a better look. Go ahead and take a look. So what did I do wrong?
It's /32?
Nope.
No.
Is there not a route to the 172?
Nope. We have a default gateway, so that'll take care of that. What am I missing? Has to do with layer 2.
So do you need to tag a VLAN or something?
There we go. Right. So if we go ahead, right, do a show interface VLAN 2, right? Which of course is VLAN 2, right? It's showing down. What that means, right, is one is not reachable via layer 1, that's not reachable via layer 2, right? VLAN 2 does not exist on this switch. So how can it pass traffic? Also, gigabit 0/1, which connects to PC5, is attached to what? VLAN 1, right? So that's not going to work. So we need to go ahead and make sure we assign it to the right VLAN. Okay. There we go. Now let's go ahead and verify our work. There we go.
Okay.
All right. Let's go ahead and check our work. And let's check the other side too. Okay. All right. So, 3. All right. It's already looking wrong.
So the problem was on the switch side, you didn't have VLAN 2 configured. Is that
That's
it?
correct. That's correct.
That's it. Okay.
Let's go ahead and configure that. And also, twofold, right? We didn't have the port assigned to the correct VLAN. So it's twofold.
Okay, so is it gigabit 0/1 that is assigned to the wrong VLAN?
That's correct.
Okay. And gigabit/1 on switch 4.
Mm-hmm. Now
So
let's
that,
go ahead and check out. Go ahead, Mikey, I'm listening.
oh, I was just trying to figure out what gigabits are supposed to be on the default VLAN and then the ones that are on the secondary VLAN, like, other VLAN IDs.
Mm-hmm. Yeah, so if you look, right, so we don't have, right, we're not doing, routing on a stick, right? So we need to make sure, right, we have a default VLAN that's going to go ahead, or VLAN that's untagged, I should say, that's connecting to our firewall, right? So that's going to be VLAN 1, okay?
Right,
And
which is,
so, go ahead.
no, go ahead, sorry.
Yeah, so that'll be gigabit 0/0, okay? And so that's the 172.16.1.0, okay? So if we do run interface gigabit 0/0, right? We see that, right? And we see 1, it's in the right VLAN, right? If we do a show run interface VLAN 1, all right? We see, right, it's in that subnet that is the same as the firewall, correct?
Right.
We do the same thing here, right? Now we have a VLAN that's dedicated to, of course, that secondary VLAN, the end user VLAN, we'll call it. Okay?
Gotcha.
Make sense?
Yep.
Yes.
Okay. All right. So now that we have everything in place, right, what do we expect? We expect now that we can go ahead and process our pings, right? Let's go ahead. Let's go ahead and pull up our logs. Let's go ahead, right? Because we didn't even see any denies reach the firewall. So, of course, that's how we knew it was a layer 2 issue. Let's go ahead. Go to our packet captures. We're still running. So now, let's go ahead. PC5. Let's go ahead and reset the terminal. Go ahead and clean it up. All right, so we're still getting a timeout, right? Let's see if it's touching the firewall. Okay, we're getting packets. This is amazing. All right, now let's go ahead and go to the logs. All right, we'll go ahead and let that packet capture. Let's take a look. Excellent. Right, so the source 192.168.2.50, destination 192.16.2.50, right? Let's take a screenshot of this. Right? Because this is how you build your firewall policies, is what you see in your denies, right? So we see pings, right? It's trying to reach or leave out a certain port, right? And go through a certain port, right? What do we see here?
Port 1 is the outgoing
Interface, right?
Interface, yeah.
Okay. Let's go ahead and let's go back to the topology. Why is leaving port 1 the issue?
Because it should be going out of port 2. Well, no, not 2. Port, is it 4?
Where's your destination network? Here's a screenshot. Where's your destination network?
Oh, a PC6 basically.
Mm-hmm. So what's the issue with this one? Why is it being denied?
Firewall policy configured for that traffic?
Let's take a look. So there are firewall policies, but do I have indicated IP addressing subnets?
No.
No.
Okay. So what could be the issue? Put on your network engineering hats on.
Back to that screenshot. Can you put it up here,
Sing back again.
please?
Angel, stay out of it. I want this to just be them two because they're still learning routing and switching.
There is not a
Oh,
firewall policy configured for port 5 to port 1, right?
Okay, let's look at the topology again.
Okay, maybe I'm tripping. Never mind.
Where's our destination network?
on port. I want to say port 4, but I might be wrong.
You're looking at the topology. Where is our destination network?
The destination network is 172.16.2/24.
Okay, so where does that live within the topology?
That network lives off of
Port 5? No.
port 4 and 5. Is that it?
Which firewall does it live off of?
HQ2?
Headquarters 2. So what firewall is he in?
Okay, we're in HQ1, right? So if that subnet lives off of
A different
HQ2,
firewall. Are we using the wrong firewall?
nope, that's not the root cause. So
Okay.
take a step back. I don't want you to focus on configuration right now. We need to look at this as a holistic approach as network security engineers. If our destination is hanging off of another layer 3 device, right? Because our source is 192.168.2.0. Our destination is 172.16.2.0. What is the path it is supposed to take? And what is the path that the log is telling it's taking? And with that information, right, what are we missing?
Um,
Take your time to think. I don't want a speedy answer. I want the right answer.
I'm gonna say port 5
Port 5 what?
on HQ because that's the connection to HQ2
So how do I know about port 5 on HQ1?
because of the connection on port 4. Can I get some help, guys? I'm gonna keep you.
I'm thinking about what's the best route? I mean, do we need to look at the switch routing table to figure that out?
Look at this firewall policy.
Okay.
Look at your topology.
It's going to port 5, and the
What is the
destination is port 1.
what is the log telling you? What does the action say?
The source IP of the 192.168.50
No,
is
stop. What does the action say?
Deny,
deny.
Deny what?
policy violate.
Okay. All right. Deny policy violation. There's policies in places already, right?
Is the
Right?
action set to deny?
There's policies in place already, correct?
Yeah.
Okay. Let's look at this screenshot again. Deny policy violation. Source 192.168.2.50. Destination 172.16.2.50. Let's go to the topology. Where does 172.16.2.0/24 live?
On HQ2, HQ1.
So why is the deny policy, right? Why is this log telling me that I have here to get to 172.16.2.50, I need to go out of port 1? What is that telling you guys have network security and engineers?
And it's just sending it out to the internet if it goes out of port 1.
Okay, but where should it be sending it to?
HQ2.
Okay, so what does that tell you that we're missing?
Is it a reverse policy?
Mm-mm. What does it tell us that it's missing?
The interface that it should be going off.
What is it telling us that it's missing? Put on your network engineer hats. What is it telling that we're missing?
Okay. Let me take a step back. Hold on.
Please.
Because I feel like I'm overlooking it.
You guys are absolutely overlooking it.
What is it missing?
What are we missing on our firewall? Why isn't traffic passing? And you guys need to know this, because when you guys become that engineer for those organizations, you got to be able to read it.
Can you wait, let me take a screenshot of this. Hold on.
For sure.
Can you pull back up the actual the policy?
Sure. Take a look at it.
Okay. So HQ1 is on. We have coming from port 5, going to. Is it because it's, well, no. Are those WAN interface sets configured?
Like, I don't know if we're just missing the source subnet or destination subnet.
Keep going. Keep going. You're on the right path. Put on your network engineering hat. What are we missing?
The source and destination subnet?
What are we missing? Where would you look first for troubleshooting to discover if we're missing subnets or not?
And the static routes.
Okay. Mikevia, what are we missing?
Oh, 172.16.2.
There you go.
The freaking static route. Oh my God. That's aggravating.
You guys are network security engineers.
Like, what are we doing?
Okay.
So we were trying to adjust the policy and it's.
We ain't got no route to where we need to go.
Oh my God.
Oh my God.
Oh my God.
It's all good.
Sound like
This would have been an hour call. And
Right.
it's like a 10-minute fix.
Right.
Oh my God.
Gotta slow it down sometimes, man. You guys are just not security, you're network engineers as well.
I thought we added
But
the
I
routes
was on the
though.
right track a little bit, but I said let's look in the routing table on the switch. I should have said routing table on the firewall.
Yep. Yep. Because what was your biggest indicator? Your indicator was we saw traffic touching the firewall. Our issue when we didn't see traffic touching the firewall was what? It must have been at layer 2 at the switch, because it's not going to that next hop. Okay.
All right, that's why I was getting denied.
Okay. Not so much getting denied, right? Before we added that route on the switch, we didn't have a route on the switch, right? So that traffic was being dropped. So now let's add the reverse.
Wow.
Good job, guys.
Why, thank you. I'm gonna pat myself on the back for that.
Good job.
Oh, yeah. Yeah, good job. All right. So let's go ahead, check our traffic. All right.
Wow.
Some traffic passing. Let's go ahead. Now we see pings rolling. Any questions?
It's clear now.
Okay.
Oh my God.
Good job, guys. But guys, again, we're on the routing section, right? And I did this on purpose, right? Because I want you guys being, you guys are going to get your NSE4, right? Your network security engineer level 4 from Fortigate, right? So whenever we're going for you guys get the certification, that's perfectly fine. That's cool. Nice and dandy. But you guys will go to these organizations, maybe stay with your organization or go to another organization, has NSE4s. What you're being entrusted with is A, being a network engineer, B, being security engineer, C, being a help desk, right? Assistant or what have you, right? You have to have all these skills. Okay. So you need to put all of this together, right? But sometimes that's a lot, right? How are you able to go ahead and reference all of it, right? I'll go ahead and give you advice. This is where the OSI model will always bring you back home. Okay? There's no way for you to remember everything. The OSI model will always bring you back home. I want you guys to remember that. I want you to print that out, put it on your desk, your work. Understand how that works from a troubleshooting perspective. That make sense?
Yep.
It does.
All right, guys. Well, I'll go ahead and close the lab here, and I will speak to you guys tomorrow.
All right.
Take care,
Thanks.
guys. Bye.
All right, guys. Bye.